Remember to sign in to the Meet Echo. Yeah, let's go ahead and get started. You ready to go? Yeah.
Okay, let's get started. Welcome to the LSVR working group session on IETF 123. And as always, this session is being recorded. Okay, here's a note well. This is the reminder of IETF policies on patents and the code of conduct. Since it's already Thursday, I assume most of you have already noted very well. And if not, please read this carefully. And here's a note really well. It's about the IETF guidelines for conduct. And this is important for collaboration in IETF and for the proper behavior to each other. Here are the meeting tips for the IETF meeting for both the in-person participants and also the remote participants. Basically, we would need to use Meet Echo, both for the blue sheet and also for the discussion on the mic. And here are the resources for the meeting. And here is the agenda for this session. We have the working group updates, and then we will continue the discussion about the BGP SPF neighbor discovery. We have two proposed solutions, and we will continue the discussion on this session. And the last one is one individual draft on the extension or applicability of SRV 6 to BGP SPF. Here are the working group updates since last meeting. We have two new RFCs, the base BGP SPF document and also its applicability in the data center. Both has been published as RFC. So congratulations to the authors and also the shepherds on their hard work. And for the other working group drafts, the BGP LS Young document has expired since April 24, 2024. And according to the feedback from the authors, they are working on the resolution of the received comments, and they have planned to provide an update after this meeting. For the L3DL draft, it's on today's agenda. There's a recent update to address some of the security directory review comments, and we still need to continue this discussion and then respond to the liaison from IEEE 802.1. After last IETF, we had a working group interim meeting on May 6th. The meeting materials and the notes can be found on this page, on this data tracker. We had presentations on both L3DL and LLDP-based neighbor discovery mechanisms. We also had good discussion on the similarity and difference between the two proposals and whether all the requirements for peer discovery can be met by these solutions. There were some questions and discussion continued on the mailing list. However, we haven't reached the conclusion on how to proceed and respond to this liaison yet. So we need to continue the discussion during this session. We also invited colleagues from IEEE 802.1 to join the session. Thank you very much. Regarding the requirements on the BGP SPF peer discovery, there's no standalone requirement document on this, but we have some text about the requirements on this connection discovery and the liveness detection, both in the RFC 9815 and the 9816. In 9815, it says that for the peer review models described in the section 4.2 and 4.3, direct connection discovery and liveness detection for the interconnecting links are independent of the BGP protocol. So if this indicates there's some other mechanism needed for this. Then in the RFC 9816, it provides peer discovery considerations and the requirements in the data center scenario in the section 5.4. Basically, the basic functionality for peer discovery is to discover the address of the single hop peer. And it also mentions that it may be useful to have the following information related to the BGP session being discovered, including the autonomous system number, the BGP ID, and also security capability, the session policy identifier, which can be used to associate with common session parameters with the peer. And also it can be used to install the routes towards the potential peer loopback address. The last one is about there is a requirement to establish a multi-hop session with the controllers in some of the peer models described there. So I think this can be some information or basis for today's discussion. Maybe helpful. Okay. Any question or comments on this slides or the information provided here? Or okay.
Okay.
So let's move on to the first topic of today's session. I think for the discussion, maybe we can first let the L3DL authors to give some brief update of that draft recently. So maybe Q is busy. Yeah. This agenda here.
Oh, you are going to do it. Okay.
Do you want to come
I
to
don't
this
know.
mic?
I'm not.
Yeah.
K. Patel Arcus. We haven't made a significant progress from the last IETF, but I believe the um, idea of using and piggybacking on LLDPV1 for the hellos is something that we are considering, and hopefully in next few weeks we will have our side of the story sorted out pretty well. Yeah. So that's a short update from our side as an authors.
Okay, thank you. Is there any comment on this L3DR draft? We will move on to the presentation of the LLDP one. Okay, so Paul?
Hi.
I will share the slides for you and you can have the control.
All right. So,
Let me, wait.
so how do I control the slides?
Let me try to stop first.
G's bringing him up, then he can transfer control, and you should see something on the left. I mean, on the right.
Yeah, I have
On the right, says you got slide control. Okay. Right. I hear a lot of echo. Is it coming through okay out there?
Yeah, you're coming through loud and clear. I hope everybody has the on-site tool on here and nobody's using the full client, because that could cause an echo.
All right. Yeah, still not too bad here. Anyway, all right. So I've just a review of some of the things that we've been at. So just as a recap, we do have a liaison from the IEEE 802.1 working group regarding the use of LDP for the discovery. And also we have extended LDP to allow for large data sets, which might be required for LSVR. We also have a number of contributions in front of the committee, which include materials, draft Bottorff, which was just updated, by the way, to version 01. So LDP is basically a database exchange protocol. And the way that works is that information, like for instance, the addresses that are discovered, are stored in TLVs within the database, which can be represented in Yang models. And LDP is then responsible for advertising that database information across to all the neighbor nodes. So it's a very simple database exchange protocol. So
There's one question. There's somebody at the queue. We'll let them answer.
All right.
Ask the question. It's Anwar.
Yes.
That's her, right? Did you mean to be at the queue?
Okay, I can remove. Yeah.
Removed themselves.
Please continue.
Yeah, please continue.
All right. All right. So
It was one of those butt queues.
So this is just a quick summary, but basically there is LDP version 1 and LDP version 2. The version 1 LDP uses a single frame, which was the maximum size of the database, which has been extended by IEEE now to allow a large number of frames for the database. So you can have large sizes with LVDP version 2 or XLDP, as it's referred to at times. So I had wanted to go into a little more detail about LDP in terms of reliability. So LDP basically uses a multicast hello of a single packet, which is based on LDP version 1. That single packet is transmitted periodically, but also on any change event within the database is transmitted immediately. Not only is it transmitted immediately, but it's also repeated on a fast timer for a period of time to make sure that it picks up right away. The extension frames, which are those beyond the single initial hello frame, are identified by a TLV inside the database that is carried in the initial frame. And that informs the receiver of all the potential PDUs that need to be transferred. those PDUs are transferred on unicast addresses and are based on requests from the receiver, which basically can retry those requests in the event information is lost. So basically, you have a unicast transmission of frames, and the frames that are transmitted are based on only those frames that need to be updated. So the manifest TLV, as it's called, which includes the information for all the extended PDUs, contains a digest and information that is used to determine whether there's any change in each one of the PDUs. And so if there's no change in the PDU, then the receiver doesn't request any updating. Okay. There are other, I had one to point out, there's one other advantage to this, and that is that this is driven by the receiver. And so that does have an advantage from the point of view of processing load. The receiver knows how fast it can process the incoming frames and can basically pace the information at a rate that is acceptable to its processing rate. And this is important when you have control planes that may be bogged down doing other things or with limited buffer spaces, which is not uncommon, inside routers. So I want to talk some about addressing. Draft Bottorff describes using a nearest router address for basically the LDP multicast, which is equivalent to the hello packet. That's because in this example, which is an example of switch virtual interfaces, this is a common router arrangement where the switch virtual interface is actually generated by a bridging layer that sits on the physical network and separates the routing layer from the physical layer and is used then to direct information to the router switch virtual interfaces. By using a nearest router multicast address, the address can transfer through these bridges that sit at the base of the routers and generate switch virtual circuits all the way into the actual router physical port. Okay, so my recommendation has been to use a nearest router scope MAC for LDP, which will then be something that would be selected by IANA, for instance, and specified specifically for this application. So the L3DL protocol identifies each one of the router ports with a logical link endpoint identifier. And in fact, LDP also has the equivalent identifier, which is the chassis and port ID. If what's done is you use the nearest router multicast address, then the chassis and port ID are fully equivalent to the identifier of the LLEI in L3DL. And so they represent then the actual address of the router port within the end device, and so can be used there. The LDP can have an IETF, organizationally specific TLV set, which can carry all the addressing information and other information that you wish about the edge ports. These would have to be defined, and Draft Bottorff identifies how to define all the TLVs that are equivalent to L3DL. Right, so all the information that L3DL transfers is included in draft Bottorff TLVs. And they're encoded in this format where you actually have an organizationally specific LDP TLV, which is identified by an IETF OUI, and a subtype which would identify LSVR, and then an LSVR type that would identify the TLV identifier, which would then identify what the encapsulation types were, etc. So from the point of view of liveliness, LDP itself is a liveliness protocol. It sends and specifies a time to live and repeats based on a timer. The granularity of time to live, though, for LDP is in seconds. Might be many seconds, actually. IEEE also supports, though, connectivity fault management, which is an additional protocol that is an end-to-end management protocol for L2 networks. And it basically can give you liveliness down into the millisecond range. Its minimum time granularity is about 10 milliseconds. Finally, the Ethernet Committee 802.13 also supports an OEM liveliness, which only operates on a link-by-link basis, but nevertheless can give granularity down into the microsecond range for very fast recovery. And this can then be propagated up to the router to indicate, a failure occurring very quickly. So I have my summary for applying LDP to the link state virtual routing discovery and configuration. So we've seen that discovery can be achieved by running LDP at the link state virtual router logical link endpoints, right? Which is enabled by using this nearest router group address that would have to be assigned, and that are identified by the LDP chassis ID and port ID, which identifies the database endpoints. We have discovery of L3 and L2.5 encapsulations using the TLVs, which are documented in draft Bottorff. And so the database would be built with all the TLVs, which can be a large number of addresses, very large number of addresses. So on top of LDP, though, LDP would only build the database with the information. There would need to be an application sitting on top of LDP that would extract the database information and validate it. So that's something that would have to be done by the committee in addition to using LDP. So LDP wouldn't be the final step. It's providing all the information that's needed, but that information would have to be reduced by an application inside the router. Right. So any of the interfaces can be used. So I've only shown an example of a switch virtual interface, but the same techniques will work for direct physical interfaces or for sub interfaces or any other type of router interface arrangement, which is one of the beauties of the scheme. You have one scheme which works in the most complicated case, but also works in all the simple cases also. So L3 liveliness can be enabled simply by a indication in the TLVs, which is also what's done in L3DL. And L2 liveliness, there are options. If you just use LDP, then you get liveliness in the order of second ranges. But you could use connectivity fault management also, which would give you millisecond ranges of liveliness. So, so you can also communicate all the parameters needed through the TLVs for BGP. And LDP can also be secured with MACsec, which is the IEEE technique for security. So I guess as it stands, I'm requesting the adoption of draft Blautorf for LSVR discovery. And so that's the end of my presentation.
Thank you, Paul. And AC, you're in the queue.
Yeah, AC Lindemarcus, you said something interesting that the committee would have to do about, are you seeing standardizing the application interface to disseminate the information to other,
Well, so the committee
as part of something that would have to be standardized? I didn't really understand that statement.
Right. So it might not have to be standardized, but nevertheless, LDP doesn't talk directly to BGP. It builds a database of the information, and then the LSVR router would have to, validate and reduce that information.
Right, as you'd have to do with any discovery mechanism.
Exactly. And so, but LDP doesn't do that for you.
No, I think implementers understand that.
Yes. Okay.
And Ross?
So my understanding is that the authors of L3DP are looking are looking at this technique for replacing the hello message that is in the current draft, so that they LLDP will be used for all of the layer 2 discovery pieces, and then everything else will happen at layer 3, including the liveness check, which will be done with BFD. That's, I believe, the direction we're going. Is that not right?
So BFD is always an option, which can be enabled in LDP also.
Q?
Yeah, Khair Patel Arcus. We have reasons to believe that you don't want to pollute BFD for this. We want to keep it quite simple to exchange the endpoint information. So I think, Russ, you summarized it perfectly. Thank you.
Okay. Next is myself. As a working group member, I'd like to have a quick clarification question on this TLV 127. Can you go to that page?
TLV.
LLDP IETF organizationally specific TLV.
Oh, right. So
Yeah.
right. So yeah, the organizationally specific TLV. Right.
Yeah.
So this is part of the LDP standard.
Yeah.
which basically provides a way for organizations to specify TLVs of their own. Okay. And it specifies this format, which is um, all LDP TLVs are type length encoded with a 7-bit type and a 9-bit length. And the organizationally specific TLVs are then identified immediately by an OUI, which identifies the standardizing body. Now, this OUI is an IETF OUI, which is owned by IANA and can be used for this purpose, right? And so past that, then there's a subtype. So up to this level, this is the organization that is required for LDP through the subtype. Then past the subtype is all information that is up to the committee, the organizer, whoever owns this OUI to define.
Okay, so it means that all this IETF specific information will be carried under this TLV, right?
That's right. And it will be compatible with all LDP implementations.
And is it allowed to carry multiple this TLV in the?
Yes, absolutely. And so actually draft Bator specifies that, but the TLVs are limited in size to 512 bytes and 511 bytes actually, but you can have as many of them as you like in the database. So if you have a lot of addresses, you can have 100 of these TLVs in there. Each TLV can carry a bunch of addresses.
Okay, thank you. Are you still in the queue? No. Okay, Keaton, please.
Yeah. Hi, Paul. Paul, thanks for the presentation. I saw that you had asked for adoption.
Yes.
I also heard that Russ and Keyur mentioned that the L3DL draft authors are looking at leveraging LLDP for the discovery part, I understand, and then build the other TLVs on top of it into L3DL. That's, I think, what I understood. I would like to know your views on that.
Right. So first of all, it is viable to do that. Okay, technically that can work. I guess the other view that I would have is that I'm not sure it's necessary to have another protocol, since offhand, I don't see the real advantage to L3DL in terms of the transfers. You can transfer as much information, I believe, with extended LDP, and I believe the reliability is, equivalent or better, and the industry support is broader.
Okay, thanks for that. If I may have a follow-on question, you referred to the draft AC IDR LLDP peer discovery, which is again sharing more information for a different use case than LSVR.
Yes.
And could you clarify the relationship between, or how you see the relationship between draft, your draft and this draft?
Right. The reason I mentioned this draft is that this draft is using this format of the subtyping, right? Which then is duplicated here and within draft Bautorf. which basically uses a subtype that identifies the committee. So this would be LSVR in this case, and then another subtype to identify the specific type of TLV. That's the part that is actually pulled from draft ACI.
I see. Okay. I mean, of course, it's for the working group to decide. But as far as I know, in IETF, under IETF IANA, there is actually perhaps maybe I mean, it's not precluded to have a flat code point space under IETF IANA, which means that another level of hierarchy may or may not be necessary in that case. But anyways,
Anyway,
that's a technical part. Okay.
right, and so I would agree with that point of view. So
You would need a registry. The draft AC BGP neighbor discovery was was the first one to allocate subtypes. So
Yes.
you would need an IANA registry.
right.
Sure. Okay, thank you. And question to the chairs. What's your plan on handling the adoption request and reconciling with the other thing that we heard? How do we plan to do that? I mean, maybe not discuss here, but think about.
Yeah, Q, please.
K. Patel Arcus. I think we should take this discussion on the mailing list because we really want to have a one more time a detailed conversation as to what were the motivations with L3DL versus LLDP based mechanism. I again want to be super clear that the authors are looking at portions of LLDP to see how we can leverage and build upon it such that you can sort of come across and leverage LLDP as much as possible. But there are reasons why we came up with L3DL, and those reasons should be well discussed on the mailing list as opposed to here.
Okay, thank you.
And I just want to add one more thing, that I'm an author on both the drafts. So I can tell you pros and cons of why one versus another, and as a routing vendor, what makes sense, what doesn't make sense from a vendor perspective. So I think that would be a good conversation to have on the mailing list.
Yeah, that makes sense to me.
I'm just capturing this in the notes, the minutes.
Any other comments?
Yeah, so I'm all for debating this on the mailing list. After the interim, we had such a suggestion, and there wasn't actually much back and forth as a result of that.
Keaton?
Yeah, I would really encourage the discussion to actually happen on the mailing list between this and the next IETF. Yeah, that's the best way to engage, as Keyur mentioned, on this and come to a resolution. All the discussion analysis happen there. Thank you.
Thank you, Q. Thank you, Keaton.
The chairs would like to see a decision as well before the next IETF.
Do we need another interim if necessary? So please use the mailing list for the discussion. Yeah. Okay. And thank you, Paul.
Thank you.
And now we come to the second presentation. It's from Li Zhang.
Yeah, can you hear me?
Yeah, do you want me to hand you the slides control?
Okay, I can control. Okay.
Okay.
Okay, hello everyone. This is Li Zhang from Huawei. I will present the draft on applying BGP-LS segment routing over IPv6 extensions to BGP SPF on behalf of my colleagues. Okay. And so in this version, we enrich the existing sections with the TRV usage and also the formats. And we also added the advertising endpoint behaviors section to describe the endpoint behaviors that can be advertised by BPSPF. And we also added the acknowledgement section to thank those uh, who provide valuable comments for this draft. Okay. Okay, let's start from the SVR6 node attributes TLVs. The first one is SVR6 capability TLV. It is used to announce the SVR6 related capabilities of the node. It's a mandatory TLV in the BPSPF node attribute and must be advertised only once. If the SRv6 capability TLV is not advertised, then it indicates the node does not support SRv6. Okay, and the second TLV is SVR6 node MSD type TLV. It is used to advertise the limits and the segment routing header operations supported by the SVR6 capable node. It is an optional TLV and must be advertised only once. If there are multiple MSD types that have the same code point in a node MSD TLV, then the node MS TLV must be ignored by the receiver. And the third one is the SR algorithm TLV. It is used to advertise the SVR6 algorithms supported by the node. It is also an optional TLV, and algorithm 0 is supported by default. It must be advertised only once. If SRv6 capable node does not advertise this TLV, it implies the algorithm 0 is the only algorithm supported by the node. And if originating node advertises the SR algorithm TLV, then the algorithm 0 must be present. Okay, from this page, I think the following several pages will introduce the SVR6 link attributes TLVs. The first one is SVR6 end dot xseed TLV. That is used to advertise the SVR6 says corresponding to a point or adjacent of the node. It is also an optional TLV, and more than one instance of this TLV can be included in the BPR SPF attribute. Uh, Multiple SY6 and dot X seed TLVs may be associated with the same agency. And all the n dot X seeds must be a subnet of a locator. And the next one is layer 2 bundle member attributes TLV. It is used to advertise the layer 2 bundle member link attributes when the layer 2 bundle member link is associated with a parent layer 3 link. Considering that BPRS SPF may also include the trunk link scenarios, so BPSPF may also support it. It is an optional TRV, and multiple layer 2 bundle member attributes TRVs may be associated with a link NRI. And the advertisement must be withdrawn if the link becomes operationally down or it is no longer a member of the LR bundle. And the third one is the SR6 link MSD type TRV. It is used to advertise the limits and SH operations supported on the specific link by the SRv6 cable node. It is also an optional TRV and must be advertised only once. Okay, and the SRv6 prefix attributes TRVs only includes one TRV, which is the SRv6 locator TRV. That is used to advertise the locator supported by the node. Multiple SRv6 locator TRV may be advertised with a different locator. If multiple TRVs are received for the same locator, then the receiver must use the first occurrence. And since the flag fields are not used in BPSPF, so it should be set to 0. And also because BPSPF defines the prefix metric TRV is mandatory for prefix NRI. So the metric field in this TRV is no longer usable, so it also should be set to 0. Okay, BPRS also defined the seed NRI to carry the SY6 seed information. The seed NRI includes the SY6 seed information TRV. It is used to advertise the SY6 seeds associated with a node in a SY6 seed NRI. It is a mandatory TRV in the SY6 NRI, and each NRI must contain a single SY6 seed information TRV. And the SR6 seed must be allocated from its associated locator. This is the same as the previous. I think is and dot x seed. Okay, and there are also some seed attributes for the seed NRI. The first is SVR6 endpoint behavior TRV. It is used to advertise the behaviors associated with a seed. It's a mandatory TRV and must be included once. And the SY6 seed structure TRV is used to advertise the length of each individual part of the SY6 seed. Is an optional TRV and must not appear more than once. It can be used for the n.x seed and the SY6 seed. And this theory must the sum of the different parts of the theory must be less than or equal to 1 and 22 bits, 28 bits. Okay, we also added a new section which is the advertising unimportant behaviors to introduce which behaviors are supported in BPSPF. And okay, so for the next steps, we welcome for comments and also suggestions. And we also think we have made a bigger progress since the last version. Is it ready for working group to consider adoption? Okay, that's all. Thank you.
I guess I'm the only one in the queue. The one thing I'd like to see, I see the TLVs are much better defined in the validation, you know, of these existing BGPLS advertisements. But what I'd like to see, I'm not going to make you do pseudocode like is in the base document 9815, but it would like to just, you know, it's a pretty simple single, it's equivalent to an IGP single area SPF. Just go at a high level, talk about when you use these and what you install for each one with, and you can use references to the SR architecture. You don't have to, you know, reinvent that, but it would be, rather than just have a definition of TLVs, do what the IGP documents describe when you're, you know, when you're using these TLVs and what you're installing in the, both the in the rib and or in the I guess everything for SRv6 is in the IPv6 unicast rib, or I guess you even have algorithm specific TLVs. So does that imply that we're doing flex algorithm? I mean, I think you need, if you're going to have all this functionality, you need more definition than just the TLVs. You can't just say, well, the IGPs do this. Here's the TLV. You at least need to describe it at a high level, and you could reference the applicable sections in the OSPF or ISIS documents, you know, at least for each of these behaviors, because you've got probably, with the TLBs, the background on this is probably tens, if not hundreds of pages of LSR RFCs.
Yes. Okay. So you mean we can remove the redefinitions in this draft, which is
Right. I'm not telling you have to do pseudocode like is in the base document. You know, we did that for the first one, but that was a choice. But you really need to point to how you're using the LSP, these TLVs, these SRv6 TLVs, and what you're installing.
Okay. So I don't understand what you mean on installing.
What you're installing in the IPv6 rib, and which rib the TLVs, you know, where you're installing it, what you're installing, where you're installing these SIDs.
Okay. Maybe we can continue to discuss this in the main list.
Sure.
Okay.
And maybe you can check the content in the IGP SRv6 documents and see whether something could be referenced, right?
Yes. Yes.
I mean, I think it would be good. I mean, it's a simple single area SPF, and you could go in as you're processing, you know, say as you're processing the nodes, you would examine all the, you know, these BGP SPF or BGPLS SPF TLVs and what you install. I mean, I don't think it's that hard, but just having the TLVs and detailed explanation of the validation of the TLVs without saying how you're going to use them, or even having a reference, I don't think that's enough.
Okay. Okay. Thank you.
Any other comments?
Oh, I'm off the queue.
Okay, thank you, Lee.
Thank you.
And we have 5 minutes remaining. Maybe Katie want to say something?
Just a quick reminder that following the IETF meeting, there is an IEEE plenary 802.1 happening in the same location. And there were few participants from the IEEE side. Probably here, I see Glenn. Okay, yeah, thanks for waving your hand. So please do use the opportunity to discuss in the hallways today, tomorrow, or next week if you are staying on. And look to see us converge on a solution soon.
So is our AD going to stay on?
Yes, until Saturday. Until this Saturday, day after tomorrow. But don't expect me to solve this problem.
Okay, I guess we're done. We're gonna kind of watch the drafts and everything to determine if we're gonna meet in, where is it next? Montreal.
So see you in Montreal. Thank you.
Hasta a listo de correr. The mailing list.
Yeah. You mean? What?
Yeah.
Please use it.
Yeah, please use the mailing list. We'll see you on the mailing list. That's what I said.
Yeah. Let's continue the discussion on the list. So when will you leave? Friday